Thank you. Okay, we're going to move on now. And, you know, I don't mean to scare you or anything, but things have been coasting along pretty good so far, because it's really amounted to, with some little extra conditions, factor and cancel. This is what we've been doing. Factor and cancel, over and over again. Today what we're going to be doing is looking at adding or subtracting rational expressions, which is an entirely different beast. We're going to go real old school here, like basic fractions with numbers, okay? We're going to add 5/7, 5/8, there we go. We're going to add 5/8 plus 7/8 minus 3/8. I want you to notice that I didn't say we're going to add 5/8 plus 7/8 minus 3/8. I'm saying we're adding 5/8 plus 7/8 minus 3/8. If I had, you know, 5 cats, and I'm going to add 7 cats, and for some reason I'm taking away 3 cats, well, these are like terms. It's like taking 5x plus 7x minus 3x. You simply go 5 plus 7 is 12, minus 3 is 9. Is my math right there, 9? That would be 9 cats. Well, that means that this is 9/8. Like literally, what 5/8 means, is that. So I've got 5/8. I'm going to add 1, 2, 3, 4, 5, 6, 7. And then I'm going to take away 1, 2, 3. Well, what do I have left? 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9/8. That's what it means. And this is where the idea comes from, that when you add fractions where the denominator is the same, you add or subtract the numerators, but you keep the denominator the same. Very, very basic kind of question. What if I give you the following situation? 5/4 plus 7/8 minus 2/3. Well, I can't add these together, because adding quarters and eighths and thirds is no different in principle than adding omelets, gerbils, and dollars. They're just different things. But we can make them the same. We look here, and this is maybe obvious for many of you, but I want to really slow down and make sure you get an idea here. We look for a lowest common denominator. And I'm going to show you how we can determine the lowest common denominator after somebody tells me what it is. What is the lowest common denominator, also known as the least common multiple here? Yeah?
24.
24. So you're saying then that 24 is a number that we can convert all of those to by multiplication. I can multiply 4 by 6 to get 24, 8 by 3 to get 24, and 3 by 8 to get 24. But it's the smallest one, right? Like 12 doesn't work, 16 doesn't work. Would you agree? So I don't know who taught you Math 10, and it doesn't matter, but maybe in Math 10 you were taught, well, I take 4 and I start writing multiples of 4. I take 3 and I start multiplying or writing multiples of 3, 3, 6, 9, 12, 15, 18, 21, 24, etc. I take 8, 8, 16, 24, 32. But the smallest number that is common to that list is 24. Are you with me on that? We need to expand our view of why it's 24. And what I want us to do is rewrite this very simple question so the denominators are factored. How many of you in the past, I know this is, you can't always remember everything, but how many of you in the past have had difficulties finding lowest common denominators? Okay. Or maybe in the past, you've found common denominators, but you've discovered that they were not the smallest ones possible. You end up getting too big of a number. If you do that with numerical fractions, that's okay. You can whittle those numbers down later, but if you do it with rational expressions, you dig yourself into a mathematical hole that you cannot climb out of. So here's how we find the lowest common denominator. The lowest common denominator has to contain all of the factors that each denominator has. Let me break this down for you because it's more complicated than it sounds. The first denominator contains 2 factors of 2. That means the lowest common denominator must contain 2 factors of 2. And what I like to say here is that first denominator is represented now. It's in our denominator, in our common denominator. So I'm done with this. I don't need to look at it right now anymore. I move to the second denominator. The second denominator needs to contain 3 factors of 2. But we've already got 2. We already have 2 here. So that means we need 1 more. And this is now represented. The reason why this is going to work is I can multiply 2 times 2 by something to get 2 times 2 times 2. And I can multiply 2 times 2 times 2 by something to get 2 times 2 times 2. But when we look at the third denominator, it's 3. That means we need a factor of 3 as well. And if you take 2 times 2 times 2 times 3, you get 24. So what we would do now in our next step, once we've found it, is we would say to ourselves, I need to multiply the top and the bottom of this expression by something to make it over 24. It's over 4 right now, so I need to multiply top and bottom by 6. I need to multiply top and bottom of this expression by 3 because I want to get 24 on the bottom, and there's already an 8 on the bottom, and I need to multiply top and bottom of this by 8. And I realize this is really elementary. What do we get? We get the whole thing over 24. I have 30 plus 21 minus 16. So that's 5. I think that's 35. Somebody help me out. 35 on the top. Good. Thank you, Tyson. So we get 35 over 24. Now, just a second. Can 35 over 24 reduce down? No. Why not? I think answering that question is important. Why can I not reduce 35 over 24 down? Yeah, Christy.
None of them have the same factors.
Right, there's no common factors. There's no factor that's the same in 35 and 24. Okay. So write a rule used to add or subtract numerical fractions. Basically, convert all to a common denominator convert all of them to a common denominator add or subtract the numerators and it's over the common denominator. That's it. And I feel as though I probably shouldn't need to write that down. This is basic fraction. It's fractions 101, right? Cannot add things unless they have a common denominator. Multiply, go for it. Factor and cancel. Divide, factor and cancel. Add or subtract, no. So all of these rules that we've been talking about with fractions once again apply to rational expressions. First of all, I want to get something out of the way. I don't care about non-permissible values today. Not because they don't exist, but because I don't want it to get in the way of this other stuff we need to understand. So we're going to add these together. Well, they already have a common denominator. So we just put them together. That's it. Well, it's not it because we're not done. Can I simplify the numerator? I mean, back here with this example that we did with the numbers, and I got 30 plus 21 minus 16. I didn't leave it there. I figured out that that was 35, and that's why we ended up with 35 over 24, right? So if we do the same thing here, can I simplify the numerator? Definitely. What am I going to do here, Gustav? Right, the 3x and 5x are similar terms. I get 8x. Not sure what happened there. That's the second time today that's happened. I can add those together. I get 8x plus 6 equal over 2y. And by the way, I'm always working down. I've been trying to teach you that. Don't go equals, 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 left to right. Oh, what have we got here? A single rational expression. Go back to Thursday. What do? Factor and cancel. There's a common factor in the numerator of 2. And I have 4x plus 3 left. It's over 2y. There is a factor of 2 in the numerator and denominator, so adios, muchachos. And we're left with 4x plus 3 over y. Any questions with that example? Y is not equal to 0, but I don't really care about that. Let's try another one. Well, they both have the same denominator, so we can put them together. So I have 3b plus 2b minus 10 over b minus 2. 3b and 2b is 5b. You can factor a 5 out of the numerator. And the b minus 2's cancel, so my answer is 5. Again, I don't care that much about non-permissible values today, but are there any non-permissible values in this expression? 2, right? B is not equal to 2, even though it cancels. Okay, this is all over p minus 4. So we can put this all together. And again, you're used to this idea of mine. It's not my idea, I don't think, but it's an idea I like to stick to. You're always looking at changing things into stuff you knew how to do yesterday or last week or last month or last year. And you can factor that quadratic quite handily, I would say. It factors into p minus 4, p minus 3. This is over p minus 4. P minus 4's cancel. Our answer is p minus 3. What if the denominators are different? Well, we need a common denominator here. Let me rewrite this. This is 3x over 2xy plus, and when you rewrite it, leave some room because you're going to need to multiply tops and bottoms of these fractions by things to get our common denominator. And then we have 5x plus 6 over 3y squared. My question for you right now is I would like everybody to determine the lowest common denominator and put your hand up and down when you've written it down. See, the fact that 5 or 6 of you got it in about 10 seconds should tell you that it's more complicated than numbers, isn't it? How many of you have it and you're sure you have it? Like you're raises the hand with apprehension. Charlie, do you want to give it a crack? No, you don't? I thought you had it. Well, I won't ask you to stick your neck out. Let's find it using what I've taught you. When I look at these factors, this denominator has a factor of 2 in it, and a factor of x in it, and a factor of y in it. Our common denominator must contain a factor of 2, a factor of x, and a factor of y. It has to. I'm not saying that's the lowest common denominator. I'm saying it has to contain those factors. And we're done analyzing that denominator. And I go to the next one. Well, the next one, I'm just going to rewrite this in green, is 3 times y times y. So there's a factor of 3 in the second denominator, which means our common denominator had better contain a factor of 3. And the denominator in the second expression also contains a factor of y. And if I were to ask you right now, is 2xy represented in everything I've written for the lowest common denominator? The answer is yes. Should I put another y here because there's 2 y's in the 3yy? No, because there's an overlap, right? There was already an extra y there. And that means if we multiply this out and get 6xy squared, that would be the lowest common denominator. And to those of you that put your hand up and down at the beginning, how many of you were correct? Okay, good. That's good. So it is 6xy squared, which means we need to multiply the top and the bottom of this expression by, well, by a 3 and a y. And we need to multiply the top and the bottom of this expression by a 2 and an x. We can put these together now. This is all over 6xy squared. The top of the first fraction is 9xy. I really, when I wrote that 2x up here, everybody, I really need you to note that it's multiplying the whole thing by 2x. So 2x times 5x is 10x squared. 6 times 2x is 8x. No, it isn't. It's 12x. And now we can put them together in a slightly, well, there's nothing really we can do here, is there? Yeah?
On the top, the 6 is actually 6y.
Can you repeat that louder, please?
On the top, the 6 is 6y.
Oh, is there a y on the 6? Thank you. I'll put that in green to highlight my omission. So this is actually that? Okay, thank you for catching that, Aoki. I'm going to take the 9xy plus the 12xy and put them together as 21xy plus 10x squared over 6xy squared. Is there anything I can do here? What, Eli? Right. So factor, take it out means to factor it. At this point in time, we've crushed this question down to a single rational expression. A single rational expression, we learned on Thursday, can be simplified by factoring. I can take out an x. That's all I can take out though, right? And I have 21y plus 10x over 6xy squared. Can I cancel that x on the top with the x on the bottom? Yes? Why, Nate? Right. And I want to keep hitting this idea that it's all about factors and factoring. So the x on the top is a factor. The x on the bottom is a factor. Cancels. You're left with 21y plus 10 over 6y squared. Let's try another one. Well, what the heck? Let me ask. How many of you feel as though you know what the lowest common denominator is here? Okay. Jay, what do you think it is?
B squared minus 9.
Excellent. B squared minus 9. Do not look at this and think, oh, the common denominator has to contain b squared minus 9 for the first fraction and has to contain b plus 3 for the second fraction. Why is this flawed, Jay?
It's a difference of squares.
Right, we've forgotten to factor first. This is 3b over b plus 3, b minus 3, minus 2b minus 10 over b plus 3. How many of you, when I said, why is this flawed, were thinking because the b plus 3 is already in the b squared minus 9? It's another way to look at it. So you cannot start talking about a lowest common denominator until you see things in factored form. The common denominator has to contain a b plus 3 and a b minus 3 to represent the first fraction. And it must contain a b plus 3 to represent the second fraction, but it already has a b plus 3. There's that overlap. That means I need to multiply the top and the bottom of this by b minus 3. So we put them together, 3b minus 2b minus 10 times b minus 3 over b plus 3, b minus 3. We're getting into here, everybody, math that is a higher level math. It's not just about rational expressions. Trigonometric expressions, logarithmic expressions, polynomial expressions. All of these expressions involve the same algebra skills we're studying here. With that in mind, can somebody tell me why? This is a bit of a long-winded question for you to think about. Why do I want us to leave the bottom in factored form, but I want to multiply out the top? And don't try to answer this by actually multiplying it out and seeing what's going to happen. That's not my point. My point is, in this situation, you want to clean up the top as much as possible and leave the bottom in factored form. Why? Let me ask you this question. Why would we leave the bottom in factored form? It's about canceling. So at some point, I'm going to want to cancel if I can. And I can only cancel factors. So I'm going to leave the bottom in factored form. Why am I going to multiply out the top then? It's a tricky question. The answer is the top is neither multiplied out nor factored at this point. It's not in factored form. In order to see if it can factor, we have to multiply this whole thing out. And then compress it down, and maybe there's a factor there. So I'm going to FOIL this out. I'm going to make one mistake in my work here, and your job is to find out what that mistake is. So I did my FOIL. I'll double check my FOIL. Yep. Where's the mistake? You do not want to make this mistake. Boy, when I get calculus students making this mistake, they slap themselves on the head and go, oh man, I lost 2 marks on that question because of this. I lost 10% of my exam because of this. Zal? Right, I'm subtracting this entire thing. Okay? It's such a simple mistake to make. You just don't want to make it. What do we do when we're subtracting something in brackets? We remove the brackets and switch all of the signs. That's one way to handle it. This is negative 16b. So when I subtract that, I get 16b and then minus 30. The numerator is a quadratic polynomial, so we should write it in the standard quadratic fashion where you have quadratic, then linear, then constant. So I'm going to have negative 2b squared I have 19b and I have minus 30. What should we do now? Remember, we left the bottom in factored form in the hopes that something can cancel, right? So what should we do with the top? Aoki? Factor it out. And if you have a leading coefficient in a quadratic that's negative, I would say take that negative out first. Is it minus 30 or plus? It is minus, so plus 30. So now the question is that thing factorable? And I wouldn't waste time trying to factor it. I would do the b squared minus 4ac test. I hope, by the way, many of you see that b plus 3 or b minus 3 is potentially a factor of the top because it ends in 30. Can we do a b squared minus 4ac calculation? And somebody, when you get it, let me know what we're getting. Gustav, are you working on it right now? Okay, let me know what you get. $120. It's factorable. Wow. 121 is a perfect square. Let's see, negative 1. It's got to be 2b and b. I honestly don't remember. I'm going to try a 3 here and a 10 here. Oh, it can't be 3 and 10, can it? It cannot be 3 and 10 because then I'm putting a 10 with the 2, creating a common factor of 2. I think it's probably factorable, but I don't think we're going to get something that cancels. I'm going to go with 5 and 6 and try the 5 here and the 6 there. Well, that doesn't do it either. Negative 12. $15 and 2. Minus 15. Minus 2. Do you want to run that through your brain and see if you can get negative 19t out of it and positive 30? Okay. Does anything cancel? No. But you don't know that until you factor it to see if it cancels or not. For that reason, I would still expect you to write this as an answer. Yes, technically, if you said this was the answer, technically you're right, only because if you do more work, it doesn't simplify. And one last question. What's the lowest common denominator? If you can look at that and tell me in under 10 seconds what the lowest common denominator is, you're brilliant. You have to factor everything first. So we have x minus 1 over, I guess it would be x plus 3, x minus 2, plus, nope, minus x minus 2 over x plus 3, x plus 1. Starting left to right, the lowest common denominator has to contain an x minus 2 and an x plus 3. Going to the next fraction, it has to contain an x plus 3, which it already does, and an x plus 1. This is our lowest common denominator, which means I need to multiply the top and bottom of this by x plus 1, the top and bottom of this by x minus 2. This whole beast is over x minus 2, x plus 3, x plus 1. And just, I know this is hard on the brain, but just pay careful attention to my next point. I don't need to write x minus 1, x plus 1 here. I can go ahead and multiply it out at the same time. So I'm going to do that. X plus 1 times x minus 1. Oh, that's easy. That's a difference of squares. Minus x minus 2 times x minus 2 is x squared minus 4x plus 4. Don't forget you're subtracting the whole thing. Now you simplify the top, and then you see if it factors. And I hope you can appreciate adding and subtracting involves a lot more work than multiplying or dividing, or even simplifying a single one. This is pretty good, though, because we get lucky sometimes. We got lucky here because I don't have any quadratics in the numerator. The x squareds cancel. What do I get in the numerator? 4x minus 3. Then we're done. There's my 4x. Negative 4. Oh, 4x minus 5. My mistake. 4x minus 5. Negative 1 and negative 4 is negative 5. Why am I done? Why do I know I'm done here? Because in a couple of other ones, we got to this point, we weren't done. Right, there's no more factors that can be taken out of the top. So the only factor of the top is 4x minus 5. Well, there isn't a 4x minus 5 on the bottom. Done. Okay. So page 336, a bunch to practice dealing with adding and subtracting rational expressions. I want to just take a quick look at something. I think tomorrow will be a practice day, okay? I think giving you the last 10, 12 minutes or whatever we got here to practice this is good to get started, but I think we need a dedicated day to practice this stuff. So what I'm going to recommend to you is that you get started on these, get enough done to get some practice. Don't go, oh, we're going to be working on this tomorrow and not take it home. Do some of this tonight. I will have additional problems we can practice tomorrow. My experience is this is where the wheels fall off the cart for people. If you don't know what that means, it means this is where people get into trouble. First 3 lessons, very, very simple, and then all of a sudden it's going to snowball. And the next topic is similar to this one, but it's not the same, so it's easy to mix the two up. Okay, you need to be really solid here. So get started on these quickly.